Hi there. Here we go again. Today is the last time you're going to hear the word taxonomy and classification. So if you weren't quite zoned in with us when we were talking about this earlier, these are the few of those, this is actually a few of those questions that we know you can get them right if you'll just listen today. Now this little video is not going to be perfect. We're going to make mistakes and we're going to look stupid, but we want to make sure that you get all the information that you need so that you can understand those questions on taxonomy and classification. Now, I think this whole thing makes me think of my kitchen. I like my kitchen when nobody else is there. I have the saucers where I want them. I have the spoon, knife, and forks where I want them. And of all things, I've got my dish rags where I want them. But yet my daughters can come over and get in my kitchen, and I don't even recognize the place after they leave. I like a certain type of classification or organization in my kitchen. And that's kind of like the way science is when it tries to name all these organisms. So in a way, science is like your kitchen. Think about the grocery store. I'm having a hard time finding where things are at H-E-B. You know what's going on at H-E-B. They're redoing, and it does look nice. But one day I walked in and the whipping cream was back at the back. The next day I walked in, it's over by the ice cream. Who knows where the whipping cream is today? So we all need organization in our life, and certainly in the field of science. So today, listen up as we talk about classification and taxonomy.
Okay guys, so it's pretty simple. They basically put them in one of three categories. So hopefully you can see this. We got bacteria, we got eukaryotes, or we got archaea. That's it. One of three categories is all we have. Now we have two vocabulary words we need to distinguish. We have taxonomy and then classification. Classification's the easy one. That's putting objects into the groups. Taxonomy is the naming of those organisms or the naming of those living things. Okay?
Now, classification is nothing more than a method of organizing organisms into like groups. They look at their teeth, they look at the shape of their hooves, they look at the density of their hair or their fur, or maybe whether they're simply invertebrates or vertebrates. I went brain dead there. So classification is simply a system, an organized system of finding organisms that are related to one another. Okay? Oh, here we go. Look here, we've got different groups. These are all plants. Certainly they have some characteristics that they share. These are all animals. By looking at these, I can tell you that they're mammals. Every one of them's a mammal. And they have internal temperature. They give birth to live young. And over here, the yucky group. The group that has chitin in their cell walls. These usually are forms of decomposers, so they've got all these grouped together according to like characteristics.
Okay, now organisms are classified by about 4 or 5 different things. First of all, we have structure, okay? And then we also go back and we look at their evolutionary relationships. Now remember that thing that we called a phylogenetic tree? Okay, and it shows how closely related different species are, but we all came from one common ancestor. So that's what we call phylogeny, okay? Then we also look at embryology. Now this is the fun one. This is where you look, and do you know, without looking down here at the bottom, that this is a shark, and this is actually a lizard, and this is actually a chicken? We look at the stages of embryo, and that tells us how closely related we are. Then we go and we look at genetics. Oh, this looks familiar. We look at our DNA, okay? And we look at how similar our alleles are. You remember that day that Miss Battle kind of scared us when she told us that there's only one little piece of our chromosomes different from an orangutan? That was a shocking day. Okay, and then we also look at biochemical similarities, which is in our DNA. Now remember, we all have the same 4 letters, A, T, C's, and G, but it's how they arrange, and it's the sequence, remember that word sequence, that makes us all different.
Now, Carolus Linnaeus, wouldn't you love to have hair like that? I wonder how early he had to get up of a morning just to get all those curls in there. But he's quite proud of his hair, but he was a pretty famous guy. He's the one that sent out all the scientists, all the young men in just graduating from college or whatever, sending them out all over the planet trying to bring back all these different types of plants and animals. In fact, he's the one that actually had them gather 7,700 plants. I think I've got that right. 7,700 plants and 4,400 animals. Now, what are you going to do with all this? I can only imagine what his kitchen looked like. Now, what he did is he came up with a naming system. This naming system is called taxonomy. The word taxo in Latin doesn't mean taxes, like you pay taxes. Well, I guess there is a kind of connection, because when I pay my taxes, what they do is they look at a chart based on my income, and it says I have to pay this much money. So what he does is he comes up with an arrangement of names based on physical characteristics. So the word taxonomy, excuse me, means arrangement of names.
Now, speaking of taxa, it's T-A-X-A, taxa. We basically have 8 different taxa. Now, I hope you can see that. These are basically the groups, and we start with really general to really specific. So you can see, oh, y'all remember an acronym that I think we taught you? King Philip came over for good spaghetti, or
Kiss Pretty Chicks, or Kiss Godzilla's Sister.
Then we also have to remember that species is spaghetti because it's most specific. Now, what about the words inclusive, exclusive? Inclusive means we include everybody. So that's going to be always at the top. Now notice, we said King Philip came over for good spaghetti, but look at that word, domain. We got to not forget that domain goes first, okay? Now, so top domain is inclusive. Includes everybody. Species is very specific, very exclusive. You're also going to want to remember that the farther we go down from kingdom to species, we get less and less animals. Okay, you should remember this from a classification activity that we did. Okay?
Now, what we have here shows the classification of humans. Does this look familiar? Never seen her before in my life. But if you'll look right here, we've got the taxa. Didn't, don't kiss pretty chicks, or fight Godzilla's sister. How do you say it?
King Philip came over for good spaghetti.
This stands for the name of a particular species. So you don't just have 2 or 3 names. You've got a total of 8 names here, plus the 2 names that's your common name. These words, in other words, you fit in the eukaryota, which means all the cells in your body have a nucleus. You're in the kingdom of Animalia. You're in the phylum of Chordata, which means you have a nerve cord, and that nerve cord goes through a series of bones called vertebra. You are a mammalia, mammal. You are then in the order of primates. So are your friends, the gorillas and the orangutans. Then we kind of branch off here. The family is Hominidae. And then we've got the genus Homo. And then we've got species, look how it's written, Homo sapiens. We'll talk about writing a scientific name in just a few minutes. So all this does is show that taxa, or the classification of a human. And every organism out there has its own arrangement of names.
Now, so some scientists just use the 3-domain system. Well, remember, domain is up at the top. It's before King Philip, okay? I guess we need to come up with another acronym and say, dumb King Philip came over for good spaghetti. No offense, he's not really dumb, but we'll say he is for today. So we only have 3 domains of life.
Now, when you come up with the scientific name, that process is called binomial nomenclature.
Wowee, what a word.
Don't I look smart? Let me say it again. Ready? Because I look so
Say it in your
smart.
haughty-taughty voice.
Binomial nomenclature. That means bi is two, not bio, but bi is two. Nom means name. So 2 names, and I can't remember what nomenclature means.
List of names?
Could be.
Does that sound right?
Sounds good. Binomial nomenclature is ascribing a particular name to one particular organism. This guy right here is Panthera tigris. Wherever you go, all over the face of the earth, if you say Panthera tigris, they know exactly what you're talking about. Okay? No confusion whatsoever. Because if you use the common name, tiger, there's different kinds of tigers. But Panthera tiger nails it right there.
And what language is this binomial nomenclature based on?
Latin, which is a dead language. No one speaks it anymore. The only Latin I remember from high school, and I've shared it with my kids, is ubi es island. No.
Scratch that.
Ubi es insula. That is, where's the island? What good is that? Latin itself, though, is reserved just for science naming.
Okay, now we talked about we need to know how this tiger actually got his name. Now remember, we take the last 2 things, genus and species, okay? So when we are writing a scientific name, let's say we're going to name this plant right here. We're going to put the genus name first, capitalized, and then put our species name second, hence the S for second, and it's going to be all lowercase, okay? Easy so far. Genus goes first, species goes second, only capitalize the first letter in genus. Now, we don't get to write in italics because we're not typing, but if instead of italics, what do? It's real easy. You underline it, okay? It's either underlined or italics, never both. That's the proper way to write a scientific name. Now, why is any of that even important? Well, let's talk about it. If I call one thing, maybe, oh, Miss Battle, I know. What is the scientific name of a mountain lion?
It's a puma.
No, the scientific name.
Oh. Felis concolor.
You know what you told me the first time when you said puma? You told me a common name. Okay? Common names are important too, but what we call a puma in the north, we call a mountain lion down here.
No, that's a cougar.
Oh, it can also be a cougar. I forgot. So we have to have a scientific name to go back to because common names are quite confusing. Okay, common names, we call a skunk what, Miss Battle?
Oh, Mephitis. We call it a skunk. But if you go to Germany and you say, do you have any skunk or skunks? They're going to go, what? But if you say, do you have any Mephitis here? That simply means stinky.
I smell
And a lot of
something.
times these scientific names are just descriptions of the animal itself. One other thing, I think Miss Bryant said, common names are often just dead wrong. Poison ivy is not an ivy. A gopher, we know what a gopher is here, but in Florida it's a land turtle. So sometimes these common names not only are wrong, but they refer to more than one animal, just as she said. All right, here we have something called a dichotomous key. Notice this shows a series of birds. They all have different types of beaks. We have paired statements here. Now please remember, if you're filling out or trying to code for a particular organism and you get lost, what should you do? Start all over with number 1. So let's take, for example, bird W. It says here, the beak is relatively long and or slender, or the beak is relatively stout and heavy. Well, what would that be? Long and slender? stout and heavy? I think stout and heavy. So it says go to number 2. So we come down here. The bottom surface of the lower beak is flat and straight, or the bottom surface of the lower beak is curved. Is that straight? So that means I'm not going to try to pronounce that. Geospiza. That would be his genus name, because I can tell it's written in italics, but it's capitalized. Genuses are capitalized. So this is a dichotomous key, commonly known as a classification key, and this is one of those questions you can get right. Remember, paired statements, read them carefully, look specifically at the one organism you're coding, and if you get lost, start all over with number 1.
And guys, if this is a question on the EOC, you may need to do the process of elimination. Go and identify each 4 and make sure you're right. Because can we have 2 geospizas? No, we can only have 1. Okay, so you may have to work backwards in some cases. Okay, now we also have cladograms. Remember, this is basically our tree of life. That's what cladogram means. It shows us the evolutionary relationship. Hence the words maybe common ancestor. We all came from a common ancestor. Now this is particularly looking at dinosaurs, okay? Now, remember, we've heard that before, that dinosaurs are flying birds, right? Dinosaurs are the original birds. So that kind of makes sense when we see these dinosaurs, and then we branched off to have birds. So this is a cladiogram. Don't forget, tree of life.
Now remember, these are questions you can get right if you will read the question carefully. We've got a series of questions that we're giving you. Remember, you always circle or underline 3 key statements, or words rather, in the question itself. You eliminate 2 stupid choices. That should narrow it down. Now sometimes you're going to get to a few choices that you can't eliminate like that. You're just going to have to really do the best you can. I want you to labor on each question, because really, you can do that. You can beat the odds on that EOC if you'll just try. We believe in you, and we appreciate your attendance today and your attention. And Miss Robertson or Miss Bryant will show you the questions, and y'all can discuss them together. Later.